Chapter 9 discusses joining data from multiple tables. It is very common when working with databases that you want to grab data from two or more tables. That's the whole concept behind the relational database idea, is that you store the least amount of data in a table and you can reuse that data over and over again. We've discussed this a few times in class. So Chapter 9 is going to show us how to connect those two or more tables together. And one of the things I want you to keep in mind is that you have to join two tables that are already related. The tables are related when you create a foreign key constraint. And you have to join those two tables that are related with a foreign key constraint. So the purpose of joins, so that we can reconstruct data in a relational database, so that we can gather data from multiple tables and use that data from multiple tables in a report. We create the joins in one of two places in our select statement. The first is the where clause, but you can also create joins in the from clause using join keywords. A Cartesian product is the result of joining two or more tables. In most cases, Cartesian products are an unwanted result. However, you may intentionally choose to create a Cartesian product. One scenario is if you're testing your report and you want to have plenty of data, enough data or information displayed on your report that it wraps to 2 pages or more. And if you have a limited amount of data in your tables, it might not generate a report of multiple pages. By creating a Cartesian product, you get more results than you would really want. So creating a Cartesian product for test purposes may be intentional. So what exactly is a Cartesian product? Well, it's the results of joining two tables where you take every single record in one table, represented here with the M, every record in the first table, and it matches up with every single record in the second table. So the results in numbers would be the number of records in the first table times the number of records in the second table. So if you have one table that has 10 records and the other table has 5 records, by matching up every single record in the first table with every single record in the second table, then the results displayed would be 50 different results. Cartesian products are created typically unintentionally by simply omitting the join condition in the where clause. It's typically not something you want to do, but you can create a Cartesian product by omitting the join condition in the where clause. If you wanted to intentionally create a Cartesian product, remember I said you might want to intentionally create one for testing purposes, you can create one through the cross-join keywords in the from clause. Now, in more realistic situations, you intentionally want to match records in one table with certain records in other tables. If the record in table 1 does not really relate to or is relevant to a record in table 2, then you don't want to join them up. A good example would be if a student is in one of the classes in the class table, then you would only want that student to be matched up with the class or classes for which the student is enrolled. We'll see examples of using books and publishers. Not every single book in the book table matches every single publisher in the publisher table. You want to make sure that when you print out a report or do a select and you want to know the book and who the publisher and author is, you want to make sure that you're getting records that are directly related to each other from one table to another. And there are multiple types of joins. The most common one is an equality join. Equality join is sometimes also referred to as an equijoin or a natural join. When the data in one table matches or is equal to the data in another table based on columns. So equijoins are created by creating an equivalency condition in the where clause. An equivalency condition, that would mean where the record in a field is equal to some value or value within another field or from another table. Equality joins can also be created using the natural join or the join using or the join on. These are those join keywords in the from clause. When working with multiple tables in your select statement, the select statement, remember the whole thing is the select statement, in the from clause we list our tables. If the tables share a common name for their column, this slide's a little bit deceiving, folks. I'm not sure why the field name is highlighted or bolded. It's a little deceiving. The one we're going to talk about is the pub ID, because the pub ID field exists in the books table. The pub ID field also exists in the publisher table. And that's a common practice, because it's the pub ID or publisher ID that relates these two tables together. The publisher ID is the primary key field in the publisher table. There's no two records in the publisher table that will have the same pub ID. When the books table was created, it was created with a foreign key constraint on the pub ID field of the books table referencing a pub ID field in the publisher table. So that's what creates the relationship between these two tables. Now in the books table, you might have many records that have the same publisher ID. And I hope you understand that. A publisher is going to publish many different books. And in the Just Lee Books company, they probably have more than one book from each publisher. This particular slide is trying to explain to you that if you have in your select clause a field or column name that is in both tables, you must qualify that column name. Otherwise, you're going to get an ambiguity error. It says the column is ambiguously defined. Quite often the error messages are not 100% crystal clear. We talked about that in class this past week. So one of the columns in your select clause is ambiguous. In other words, the database doesn't know which, in this case, which pub ID field do you want. Do you want the pub ID field from the books table, or do you want the pub ID from the publisher table? In reality, it really doesn't matter, because this is what would be considered an equijoin, and the records, when displayed, after this statement is written, when we get in this where clause, the records that are displayed in our results, the pub ID is going to be the same in the books table record as it is in the publisher table record. Here's what we're going to see. To fix this particular select statement, you qualify